Hi everyone. Today we are going to discuss about a topic in physical pharmaceutics in third semester B.Pharm. So there are 5 units in this subject. In this we are discussing a small topic in solubility unit. So the thing is that how we can determine the solubility of a solid in liquid. So first of all, I would like to tell about what do you mean by a solution. So solution we can define as a homogeneous mixture in which one substance is said to dissolve in the other. So in quantitative terms, we can define solubility as a concentration of a solute in a saturated solution at certain temperature. So here we are going to describe how we can determine the solubility of solid in liquid. So in this procedure, we can determine the solubility of drug in liquid in the following steps. So it consists of 4 steps. First one, we want to select a drug, the medium and experimental condition. After that, we are supposed to prepare a saturated solution at a constant temperature. And after that, we would like to separate the undissolved drug from a saturated solution. And finally, we want to determine the concentration of the drug in the solution by analytical method. Thereby, we can find out the solubility. So this 4 step we are going to discuss in detail in this video. The first step include we want to select a drug, then the medium and experimental condition. For selecting a pure drug, first we want to ensure that the drug is in a pure state. If it is in pure state, we can get the plot like this. If you plot a solubility on y-axis and if you take the weight of the solute in x-axis, we will get a straight line like this if the drug is in pure state. Means up to this point C, we can tell the line O, see all the solute dissolve into this up to this point. At point C, what happens is that the drug becomes saturated in the solution and saturation occurs at the point C. Thereafter, that means after the C, what happens is that no more dissolution will occur. And if we extrapolate this saturation point to the y-axis, we can find out the true solubility. So this is in the case of if the drug is pure. So if the drug is in pure state, we can see the phase diagram or phase solubility diagram as we discussed earlier. Up to the point C, saturation occurs, and if you are extrapolating, we will get a true solubility. But in the case, if the drug contain impurity, the phenomena or the phase solubility diagram will change like this. The initial line in this represent the phase solubility diagram, and this initial line represents the dissolution of both the solute and the impurity. Okay, so drug is the as well as impurity. Because of that, we can see the initial line, and the next line show the dissolution of the impurity. So this line is because of the solute as well as of the impurity, and the second line show the dissolution of the impurity. And when it intersect, we can tell that the solute has reached the limit its solubility. So by this we can find out the phase solubility diagram. Apart from this, chemical solubility also very important for a product, because the chemical solubility we are considering, in some cases there's a chance of hydrolysis. So if the drug get hydrolyzed, what happens? The drug will alter the solubility. So in that case, what we are doing is that to find out whether the drug is stable or soluble or not, we are determining by withdrawing the sample periodically. Means at particular interval we are withdrawing the sample. During that time we are shaking and we will get some product, right? So sometimes it may get degraded during the time course. So what happened? Some degradation product is there, and This sample can be analyzed by either TLC, thin layer chromatography, like that. So this is the first thing. In that, first we want to select our drug. Whether the drug is pure or not, we have to find out. After that, we want to select a liquid media. In that case, we want to select the liquid media according to our intended purpose. So two concepts we have to think. We have to think about the pre-formulation concept, as well as we have to think about the biopharmaceutic point of view. By considering the pre-formulation point of view, we have to determine the solubility, especially in water, then in one acid as well as in a base. Here, normally we are using zero point 0.1 normal HCl and zero point 0.1 normal sodium hydroxide, and we are finding out the value obtained in acid as well as the value obtained in the alkali. So this will give the solubility in weak acid or solubility in weak base. In concept of biopharmaceutical point of view, solubility can be determined by using different buffers that range from 7 to 1 to 7. Thereby, we can find out the solubility profile. The next thing is that we want to select the experimental condition. Normally, we are carrying out the solubility at atmospheric conditions. Mainly, we are carrying out the solubility study in case of two temperature. One is 4 degrees Celsius in case if we want to ensure the physical stability and if it is in the short time storage. 37 degrees Celsius normally we are carrying out to support the biopharmaceutical evaluation as well as if you want to carry out in body temperature conditions. Then after this, after the selection, we want to prepare a saturated solution. So how we can prepare a saturated solution at constant temperature? The thing is that we want to take excess of the finely divided solid and we have to try to agitate continuously to maximum dissolve until equilibrium is achieved at a particular temperature. So in this case, we are trying to dissolve the maximum amount of the solute. So we want to increase what? Our dissolution. So dissolution is the ultimate aim, right? So in the rate of dissolution, we can enhance or can be increased by increasing the temperature. So at that case, we can increase the temperature. That is the one way to enhance the solubility. But the thing is that we should be cautious about the decomposition at higher temperature. Second thing is that solubility increases as the particle size decreases. We know the thing, right? So what we are doing is that we are finally powdering our solute or passing through a C100 and use for preparing the supersaturated or saturated solution. Third way is that we can increase the rate of dissolution of solution by adding small amount of immiscible solvent in which the solid is freely soluble. But in case of resinous solute, we are preparing the saturated solution by suspending. So in that case, to increase the dissolution, what we are doing is that we can use some magnetic stirrers or oscillator shaker oven or reciprocating shaker water bath can be used. In case of volatile substances, in that case, we want to immerse in water bath and we have to keep large number of samples. Then we have prepared in second step for determining solubility as saturated solution. After that, we want to separate the undissolved drug from the saturated solution. So we want to make sure that the saturated solution should not be contaminated. So what we want to do is that first of all, we want to filter the solution and we want to collect the sample. But the problem is that we have to maintain the temperature. That is the one difficulty coming across this procedure. So we can use guarded pipette for the pipetting or withdrawing of the sample, and we are using for separation we can use the cellulose membrane can be used. For example, we can use for the oxoid cellulose acetate for the separation. This can be used, or we can use small sintered glass tube can be used. These are the various, or we can go ahead with the millipore membrane filters are there, or we can use the syringe type holder can be used to plunge with the help of a syringe like that. So these are the various way of separation of the undissolved drug from the saturated solution. And last thing is that we have done, right? So we have to determine how much drug in the solution by the analytical method. One is by gravimetric method and second is volumetric method. In gravimetric method, we are carrying out in case if the solvent is volatile and the solute is non-volatile. In that case, we want to find out how much amount of the non-volatile part can be determined by heating the sample to a constant weight. After that, after obtaining a constant weight, we can determine the weight of the substance after the filtration and drying. That is carrying out in gravimetric method. Second analytical method is that volumetric method. Means we are carrying out acid-base titration and we are estimating the amount of the solute present in a solvent. So we can, in the method, we can find out for accurate estimation, we can go ahead with the spectrophotometric or HPLC methods. So these are the various determination method for finding out the solubility of solid in liquids. Hope this video is useful to find out what are the various methods and what are the steps for determination of solubility of solid and liquid. Hope this is useful. If you find useful, please share to your friends. Thank you for watching.